Here we want to find the inverse Laplace transform of big F of s, which will give us the function f of t. So beginning with the given function big F of s equals 6 divided by s to the fourth, we'll now take the inverse Laplace transform of both sides of the equation to find f of t. So the inverse Laplace transform of big F of s equals the inverse Laplace transform of 6 divided by s to the fourth. Now looking at our table of Laplace transforms, notice how we're given big F of s and we're trying to find f of t, which means we'll be using this table in this direction here. So notice how the inverse Laplace transform of big F of s is equal to f of t. So on the left side we do have f of t, and now we need to work on determining the inverse Laplace transform of 6 divided by s to the fourth. So looking at the column for big F of s, we want to determine which form fits 6 divided by s to the fourth. Well, because our denominator is s to the fourth, we'll be using this row here to determine f of t. Focusing on the denominator, notice how we have s to the fourth, which should be s raised to the power of 3 plus 1, which means n is equal to 3. Which means we must have 3 factorial in our numerator, and let's just say we don't recognize that 6 is equal to 3 factorial. We could rewrite this right side as 6 times the inverse Laplace transform of 1 divided by, let's write s to the fourth as s to the power of 3 plus 1. In this form, again, we know we need 3 factorial in the numerator, so what we could do is rewrite 1 as 3 factorial divided by 3 factorial. Let's go ahead and do that. 3 factorial divided by 3 factorial. And then we'll factor out 1 over 3 factorial so it fits this form perfectly. So we'd have f of t is equal to 6 divided by 3 factorial times the inverse Laplace transform of 3 factorial divided by s raised to the power of 3 plus 1. So again, now this fits the form perfectly, and because n is equal to 3, this inverse Laplace transform is equal to t to the third. So we have f of t equals, again, 3 factorial is 3 times 2 times 1, which is 6. So we have 6 divided by 6, which equals 1. So f of t is just t to the third. Again, we did do some extra work here because 6 divided by s to the fourth fit this form perfectly, but many times it won't. So let's take a look at one more example. Here we're given big F of s equals 8 divided by s cubed. We want to use inverse Laplace transforms to find f of t. So again, we're given the function big F of s equals 8 divided by s to the third. So to find f of t, we'll take the inverse Laplace transform on both sides. So the inverse Laplace transform of big F of s equals the inverse Laplace transform of 8 divided by s to the third. And once again, we are going to use this row of the table to find f of t. On the left, the inverse Laplace transform of big F of s is f of t. And now on the right side, because we have s to the third, we'd have s raised to the power of 2 plus 1, so n equals 2, which means the numerator must be 2 factorial. Notice right now we have an 8, so let's rewrite the right side as 8 times the inverse Laplace transform of 1 divided by s raised to the power of 2 plus 1. And again, because we need a 2 factorial in the numerator, let's write 1 as 2 factorial divided by 2 factorial. I know we could have written 8 as 4 times 2 factorial, but this method always works regardless of what the numerator might be. And now we'll factor out 1 over 2 factorial, which will leave us with a 2 factorial in the numerator. So f of t is equal to 8 divided by 2 factorial times the inverse Laplace transform of 2 factorial divided by s raised to the power of 2 plus 1. Again, now this fits the form perfectly, where n equals 2, so the inverse Laplace transform is just t squared. So we have f of t equals 2 factorial is equal to 2 times 1, or 2. 8 divided by 2 is equal to 4, so f of t equals 4t squared. I hope you found these two examples helpful.